Hello everyone, good afternoon. Dear authors and invited guests, welcome to Technical Session 1C. Myself, Harsh Soni, moderator of this session. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all to the 7th International Conference on Information and Communication Technology for Competitive Strategy, ICTCS 2022 through Zoom. I hope you all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentation and each presentation will be given 8 minutes for the presentation and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder to conclude your presentation. There's one request for the presenters that you may all please stay connected with us till the closing remarks. And now, just before we get started, I would like to invite our session chair to chair this session. That's just a second. Professor Neha Tiwari. Dr. Neha Tiwari is working as an associate professor and additional head in the Department of Computer Science and IT at IIS deemed to be University, Jaipur. She holds a doctorate in computer science and along with BSc, PGDCA, MCS, MSc, MCA, and MPhil degrees. She is a research supervisor with an experience of more than 16 years and has also supervised the students in a variety of projects. She has been a part of many academic bodies and has delivered various guest lectures, reviewed research papers, chaired the sessions in conferences, as well as conducted the FDPs, seminars, and conferences. Her research domains include networking, machine learning, blockchain databases, software engineering, and cloud computing. Thank you, ma'am, for your presence here and chairing the session.
Thank you, Harsh.
Okay, now I would like to start with the papers. Our first presenter is Spongeman Walling. He is presenting a comprehensive review on security attacks and countermeasures in IoT environment.
Before we start, can we brief them about the time duration of the presentation?
Yes, ma'am. Every presenters will be given 8 minutes for the presentation and 2 minutes for the question and answers. And in the 7 minutes, I will raise a gentle reminder to conclude the presentation. I hope you all enjoy. I hope you all know about it. Okay, ma'am. Can you start with the papers? Now?
Yeah, we can.
Really, I hope you will start the session. Yes.
Hello, am I audible?
Yes, you are.
Okay, very good evening to all of you. It's a pleasure to be a part of this conference. I thank the organizers for giving me this opportunity to present today. As mentioned, today's topic of my paper is a comprehensive review on security attacks and countermeasures in IoT environment. This will be the contents for today's presentation. I'll discuss very briefly about the IoT architecture, the types of attack, the countermeasures for these attacks, and we will conclude with the challenges and future outcomes.
We can't see your first slide. We're not able to see that.
This one, ma'am?
Challenges and future outlook.
Yeah.
So right now I am in my first slide, IoT architecture. So is this visible to all of you?
No, we are seeing on your seventh number slide.
So should I reshare my screen? Should I just?
Yes, yes, you can.
All right. so is it visible now?
Yeah, this slide is contents about it.
Okay. So this will be the contents for today's presentation. We have IoT architecture, types of attack, countermeasures, and challenges and future outlook. So moving on to the next slide, IoT architecture. Is it visible, IoT architecture?
Yes, it is visible.
All right. Okay, great. So this is a 4-layer architecture for IoT. We have perception layer, network layer, processing layer, and application layer. So I'll just briefly discuss about all these layers. The first one is the perception layer, where we have the physical objects which makes up the IoT, right? So we have the different kinds of sensors and actuators here in this perception layer, which senses the environment and performs some actions. So the entire purpose of this perception layer is to collect data, and this data collected has to be obviously transferred to the cloud or the server for processing. So this is done using the network layer. So in the network layer, we have various technologies which the sole purpose of this layer is to transfer the data from the perception layer to the processing layer, where processing of the data is done. So in processing layer, we have the cloud server, we have different, data mining tools and this stuff. So the actual processing of the data is done here in the processing layer, and it is presented to the users in this application layer. So in this application layer, we see the different kinds of IoT applications, like maybe smart homes, smart cars, and so on. So rapidly moving on to the next slide, these are the different types of attacks which persist in IoT environment. So I have broken down the different types of attacks according to layers. So in the we have physical attacks. So these are the attacks which pertains to the physical layer, to the perception layer, so to say. And we have network attacks which pertains to the network layer, and we have software attacks which exists in the application layer of the IoT architecture. These are a couple of countermeasures. This is specifically for physical attacks. So these are 4 papers. In the first paper, what the authors have done is they have proposed the work where they have used blockchain to authenticate devices which wants to join into an IoT network. So what is essentially being done here is they are using blockchain technology to authenticate devices. So here, very briefly, the principle they have used here is there is a sync node which essentially transmits sequence numbers to all the neighboring nodes, which are nothing but the IoT nodes. So here, what happens is all the nodes will receive respective sequence numbers. So the nodes which are very close to the sync node will be, of course, they will be receiving sequence numbers which are a little bit lower, and so on. So these sequence numbers is transmitted to all the nodes. So the idea here is that when a malicious node or an attacker wants to join into the network, these malicious node can be easily identified, because during this sequencing phase, this malicious node was not a part of the procedure. So when the node tries to join in later on, it will not have the correct sequence number. So in that way, it can be easily identified. In the second work, is they have utilized blockchain for device authentication. So here, what is being essentially done here is there are 2 devices here, I would say 2 classes of devices here in this second work. So we have nodes which wants to be authenticated, that is the IoT nodes, and we have one node called the hardware authenticator. So this is actually a hardware, it's an offline hardware. So this hardware authenticator, the sole purpose of this hardware authenticator is to authenticate all devices that wants to join into the network. So this hardware authenticator, what it does is it transfers something called coins to all the nodes. Initially, it transfers coins to all the nodes. So what happens later on is during the authentication phase, only those nodes which have a certain amount of coins are allowed to join the network. This means they are authenticated. And in the third paper, they have used something called secure vaults. So this secure vault is nothing but it's a vault containing a collection of keys, right? So what happens here is this: initially, this secure vault is shared between the devices and the server. So they initially shared the contents of this secure vault between the nodes and the server. So, and what is being done here is they are constantly changing the contents of the secure vault so that they don't use the same keys, right? So here what happens here is the client which wants to join, which wants to authenticate with the server, which wants to join, it sends a request to the server, and the server authenticates the client. It's sort of a mutual authentication. So the client, the devices authenticates the server, as well as the server authenticates the client. So this is being done using a sequence of challenge response messages. They exchange some sort of challenges, and in this way, the devices as well as the server is authenticated. And in the fourth work, they are authenticating devices using digital signatures. So here, the server, the server authenticates the devices, and the device in turn authenticates the server using digital signatures. So here, whenever a client requests to join, essentially what is being done here is all the communication is encrypted using private keys. So the server encrypts whatever it's sending using its private key, and in turn the client does the same thing. So in this way, they can authenticate each other through digital signatures. So that is what is being done here. So next we have countermeasures. These are all pertaining to system. So what the authors have done here is they have developed a real-time detection system which finds the attacks in the IT network. So they have developed using random algorithm. In the second work, anomaly detection, even this
Dear author, you are not audible.
I think he got disconnected. So instead of waiting for him, can we move to the next paper presenter?
Yes, ma'am.
Yeah. We'll take him after the next presentation, if in case he's able to join.
Sure.
Yeah.
Okay. So our next presenter is Manjula Gurraj Rao, and she's presenting on deep learning technique to analyze and perceive traffic sign in the intelligent transport system.
Hello, sir. Shall I present, sir?
Yes, ma'am, you can, please.
Hello, everyone. I'm audible?
Yes, ma'am, you are audible.
Yeah. Hello, everyone. My paper title is Deep Learning Techniques to Analyze and Perceive a Traffic Sign in the Intelligent Transport Systems. The authors of this paper are myself, Priyanka H., Dr. Hemant Kumar Reddy, and Dr. Sumati Pawar. So the agenda of today's topic is Introduction, Literature Survey, Proposed Model, Implementation. The later we are doing a result and discussion, conclusion, and the responses. As we know that nowadays the traffic in the road, it will be more. So to avoid this one, there will be many intelligent transportation systems has been developed. So when we are developing intelligent transportation systems, there will be a many criteria we have to consider. The one of the criteria is nothing but it is the image acquisition and the perceiving of that images. So whenever we are going to do these operations, so usually people will prefer ADAS systems, that is Advanced Driver Assistance Systems. So in our proposed model, we are having the concept of TSR, that is the traffic signal recognition and detections. So here, when we are going to recognize any images, there will be two types of images will be present. One is the moving images and another one is the stationary images. So in our paper, we have considered the stationary images. So when we supposed to consider moving images, that is nothing but it will be in the form of a video. From that video, we have to take a clips of that. That is nothing but the next perceiving of that clips is just like a stationary images. So coming back to the signs which will be detected during the roads, or some different kinds of signs will be there. So these signs will be classified into a three category. The first one is called as a mandatory signs, which will be having a red circle, and whatever the objects are will be displayed inside that one, it will be the rules supposed to be followed. If we are not going to follow these rules, the either the we have to pay the punishment, or the severe actions will be taken. The next one is is called as the cautionary signs, which will be in a red triangle. So this is going to intimate the or it is going to inform the driver, saying that there will be some problem with respect to a road. The next one is the third one is the informative signs, which will be always written in the blue block. So here in the information, if we want to know about the hospitals or a restaurant or a school, these informations will be given by these signboards. So here there will be a lot of research has been done in the area of traffic signal detections. So the one of that one is done by here, Dila Elsara. So he has proposed the driver support system intelligence systems. He has taken or he has done the system by using or taking the images and scaling that images, and removing the background. And the next one is done by Abdel Salam. And here when they have proposed this system, it is mainly with respect to Arabic languages. The next the research which has done in this area is by Saniel. So he has used the wavelet transformations and LSTM and a CNN network to identify the traffic nameplates. Usually, it is not with respect to signs. The next one, the next literature or the research which has done is by Fedrano. Here he has used various degree of illuminations along with the size of a traffic signs. If the traffic signs is very large, then he has diminished that size, and the next the classifications has been done. The next one is by using Tong 8 So he has used a CNN model to find the different type of road strategies. So the next research which has been done is by using ACRSC, that is the accelerated segmented test and a random sample, which is this is done by this is implemented for Indian roads. It is mainly focused on the traffic sign detections and pothole detections. The next research which has done in this area is by and they have a CNN method and external mechanism to detect the traffic signs. So here some other traffic sign detections are STCNA. So they have used have you also researchers, they have used the optical character recognition for getting the traffic signs. So here our proposed model, which is takes the input for the cars or vehicles to identify the traffic signs. So here the first data acquisitions, we have taken the data from GTSRB, that is the German traffic sign recognition benchmark. So where we have 40 different classes of the images as we have shown here. So once the image has been taken,
Sorry to interrupt
it
you,
will
but
undergo
we have last 1 minute.
processing stage. Crop the images. Then after cropping the images, we have split the images into testing and testing and training parts, and we are taking the classes from 0 to 42. Like this, these are the different types of classes which we have considered. Then we have used the CNN model. In the CNN model, we have used the convolution layer. In the convolution layer, we have used the activation function. There is a maximum activation function we have used. In the polling layer, we have used the softmax to identify here. So we identify. We are able to classify here what kind of images it is. So this is what we have done. This is the model representation. This model we have worked on the NVIDIA GT 920, and with the 10 approaches we are able to get the outputs. This is what the loss functions we have got. Here 39290 is the number of images, and the 30 by 30 is the size, and the 3 is the RGB contents. So in this research, we can conclude that the CNN is the most effective artificial neural networks. By using this one, we are able to identify different types of road signs. And the accuracy, when we have worked with our model, we are able to get a 95% of accuracy. The same model we can implement by using different kinds of models for a future aspect. Okay, these are the references.
Okay, Dr. Manjula, can you please come to the last slide of the presentation?
Yeah.
Not the reference one, the conclusion one. Yeah. So, is it a work of your research scholar, or it has been taken from your own research work?
This is the work of our research scholar, madam. This is only the part of a research scholar. Actually, while doing this one, we are able to identify only the stationary objects. That is also, we are able to identify around 8 to 9 pictures. Then afterwards, we have
No,
going
that
to
is fine. That is fine. Like,
yeah.
how many attributes you're working on?
Where, madam?
How many parameters you're working on?
We are worked on the parameters of this one. Image with the intensity of the images, and along with that we have taken the characteristics of hmm,
Were these the standard parameters which were taken earlier also, because you know nowhere mentioned it? And secondly, there is a gap between the
yeah,
literature review that you have done
yeah,
and in the work which you have.
hello, hello,
Hello, yes.
yes, madam.
Actually,
There is a
I
gap
was,
between
yeah,
so much I have heard. After
yeah.
that, I am not able.
Because the papers which you have taken for the reference for the review of literature,
Yeah,
I don't think they are able to connect well with the kind of conclusion which you're providing to us.
okay,
The idea is good, but I would ask you to refine the work a bit more.
yes, madam. Hello,
Yes.
yes, it is a more disturbance was there.
Okay. So are you able to hear me now?
Yeah, madam, I am able to hear you
Okay.
now.
So I'm saying whatever papers you've referred in review of literature, they are
Yes,
not
madam.
able to, complement each other with the kind of conclusion that you have provided. So this is
Okay,
one of the major gaps that I can see.
okay,
Uh, I can only suggest you that the idea is fine, but the conclusion only proves the CNN as a better approach to perform things. So I think it can be elaborated more. So
mm-hmm.
the conclusion, the review of literature, and the kind of work done, they are not complementing each other somehow. Okay.
Okay.
Yeah,
Okay.
thank you so much. Yeah.
Yeah, madam. Okay.
Can we have the next one, please? Harsh, can we have the next
Yes,
presenter,
ma'am.
please? Yeah.
Ma'am, Welling want to continue his presentation. Now he's ready.
Yeah, yeah, he can. Yes.
So, is my screen visible?
Yes, the slide is visible.
All right, all right.
Try to conclude
Extremely
it
sorry
in
for.
less time. So,
Yeah, sure, sure, sure,
Walling,
sure,
the
sure. Extremely.
slide is visible, but the contents on of your slide are not. So I would
Uh,
request you to come to the conclusion slide, right? I can see that you are talking about types of attacks and their effects, right? And then you have somehow founded some limitations also. Uh, the reference papers which you have taken. I think it's a
yes,
kind
ma'am.
of analytical paper, right? So a
Yes, ma'am.
review
It's a
paper
review paper.
basically.
Yes,
Yeah,
ma'am.
yeah,
Yes,
it's a
ma'am.
review
Exactly.
paper. So please conclude your work.
All right. Uh, so, in the majority of the papers that I have discussed so far, uh, in case of physical attacks to create a countermeasure for these different kinds of attacks, they are using techniques like cryptographic encryption techniques. So in case of IoT environment, what happens is these all these cryptographic algorithms, different kinds of algorithms for encryption, decryption, these are very power hungry, so to say. So it consumes a lot of power in case of IoT devices. So it is not very feasible. And in case of a blockchain, many of the authors have utilized blockchain to create some sort of countermeasure. So in case of blockchain, the problem with blockchain is that when we try to incorporate blockchain with IoT, IoT in Internet of Things, we have a lot of the magnitude of nodes in IoT. It's very large. We have 10 to thousands of devices. So to maintain all these devices, the transactions, the authentications, all these different things in blockchain, I think it'll be rather expensive if you are moving to the blockchain solution. And in case of machine learning, the main problem with machine learning is that the unavailability of proper data sets. So the data sets available today, uh, most of the data sets are outdated, so they don't reflect the kinds of attacks. So one of the main problem with machine learning is the unavailability of attacks. And another thing would be choosing the right machine learning algorithm to address these kinds of attacks. So these are some of the challenges that I could infer from the works that I discussed before. Thank you. So the references.
Yeah, all right. So there's one question to you. I think all the papers which you have referred talks about attacks on different layers, right?
Yes, ma'am.
Yeah, so they're not referring to attacks over a specific kind of layer, right?
Ma'am, I have divided the papers into layers. So the first four papers were addressing to attacks in the physical layer. So they are trying to create countermeasures to specifically counter those attacks which exist in the physical layer. And
All right. So you're saying all those papers are referring to the attacks related with the physical layer, right? Are you a
yes,
research
ma'am.
scholar or you are a postgraduate student?
I'm a scholar.
You're a research scholar. All right. So your
Yes.
work would mainly be about security and attacks in IoT devices, if I'm not wrong.
Ma'am, currently I'm working on intrusion detection systems. So my work is it's mainly pertaining to the network layer in IoT.
All right. And the conclusion which you're providing here is just to um, assert on the utility of, or I would say, the importance of machine learning in,
Yes, ma'am.
yeah, right. Okay. So I think it's a very, very basic paper you just started. So it will
Yes,
be
ma'am.
better if you, yeah, come up with
Sure.
something more conclusive, I would say, and important.
Sure,
Otherwise,
ma'am.
it was a good one. All right, all the best to you.
Thank
Thank
you.
you.
Thank you.
Can we have the next presenter, please?
Yes, ma'am. I would like to invite our next presenter, Fernando Gonzalez, and he is presenting on neural network designed to determine variables affecting poultry growth.
Hello, I listen.
Yes, you are audible.
My name is Fernando Gonzalez. The title of paper is Neural Network Designed to Determine Variables Affecting Poultry Growth. The authors is Engineer Gianni Lorena Incapié, Engineer Santiago Triana Ardila. This project was developed in the company Nutrabit, which is leader in the poultry sector in regional level, located in this state of Meta, Colombia. This company allowed the integration of sensor in one the shares to make measuring on the most important environment variables of poultry growth. The sensor send the measuring when every hour in the time until it spins. This project can graphically show the value of the variables over time and export this information to a database that we were training with neural networks to predict the growth in the bird. The project farm used for the study is the villas of Sabana de Rosario, for the urban area of the municipality of Castilla la Nueva, matter in the area according to the reported where the temperature that oscillate between 20 degrees and 35 degrees, the relative humidity is from 50 to 18, depending on the time of year and time of the day. The sheet has internal special measured is 100 50 long, 60 meter wide, and 22 height is a controlled environment is where there are temperatures between 19 and 32, relative humidity 16 to 18, and one speed from 0 and 4 meters depending on the date and time of the poultry growth. This condition in the implementation to measuring nodes and gateway with a chain connection teeth at the IC chain were stipulated. This first is one the center of the sheet, 150 on the first and the gateway 80 from the second node. Node 1 descend the information on the next one, the radio frequency, and the second node descend the same way the gate. Nodes 1 and 2 oversee collect the data of the environment variables and not send the collect data to the one platform through internet connection. This feature shows the connection these bytes in the mode and this implementation in the poultry, the sensors, and in data acquisition. Once the measuring variable has been carried out, the data is stored following in order measuring vector defined by server to byte the data package when it reaches the last node and separation the data to displays on the local display and then send via serial communication to be whereas small where the data is sent over the internet, the cloud store. In this case, the speed was used where variables are monitored every minute but transmitted every hour. LSD net. LCS is special recurring structure that improves the ability of the neural network to handle long dependence and its architecture is represented feature. Input gate consists in the signal layer which determines the information to be removed from the memory unit. For the gate has the function of the deciding the new information to be stored in the memory unit. This project consists in two parts. First, the summary layer does indeed determine what information is actually given continuity to the layer that responsibility that for creation so new information. Outgate is carry decision the output information. This project has two parts. First, the seed states determined by the same layer, then from the time function, the output information is then. For training should be performed scaling in training database for values can be crossed between sign these 19 different ranks. For example, the temperature in the house is between 21 and to 33, 5. Humidity between 43 to 98. The wind speed 0 pounds 3 to 1 to 9 to 3 pounds 0 8 4, and the weight the bear between 35 grams to 2000 grams. Later, the model utilizes different and sequential model is applied with the LSD network is 3 layers and the number of the neuron which is going to be trained with defined along the return sequences to set the highest time output. The H input time is the following. It's highlighted that the drawback is established in the last layer of the network in order to generate coverage and use the model. The same the data. The parameters, the net is the following table. And design the website, the provide the web application is to evaluate the bear's crown prediction in con according to the weight animal should have on the stipulated date in order to company to be sure that the animal is growing properly and it wasn't the case to have ability to take action and the right to time to make the comparison a graph is only where the right weight with respective operation and the ideal weight on the bear are suppressed. And then you can select the start date and time to view the weight in the animal as shown the fish. Conclusion, when installing the sensor in the chair, the environment condition that could affect the instrumentation had to be considered, and because of that prediction against water and bears, has to use it, so they don't to have access to this mature instrument. On the other hand, the scope of the network was determined to be able to transmit the data in real time, sign having allowed signal in the place evaluate the ocean transmission the information by cable or with wireless system in order to not have loss in the data frame. Future works include the incorporation of new variable for the recurrent network, so additive fits diverse race, this history and sensor and the journey in order to implementation. The second change as this prediction system will modify in real time that regulate the environment condition, the the house, south as temperature, water, supply, and humidity. Thank you.
Okay, Mr. Gonzalez, there's a question to you. Where have you actually implemented your work? Is it just a concept, or you have really implemented it in a physical scenario?
The implementation is in Colombia, and data is real. In this
Okay,
moment,
so
is un prototype.
uh-huh. So is that poultry farm is a private one? Did they allow you to establish your system for I would say experimentation purpose?
I don't listen.
You're saying that you
I
have
don't listen.
established the system somewhere, right? You have used this concept or this work has been implemented in a real life scenario, right? This is what you're saying?
If the scenario is real and
Yeah,
data
it's real, right? So you
is real,
must have
yes.
taken some permission to establish the same, isn't it?
So no.
Have you taken some official permission to establish uh, establish this experimentation? I would say a part of your research, some at the place where you have used it. You must have taken some permission to perform this work,
Right.
isn't it?
Like the condition, the data, the company permits had permissions for data acquisition.
Okay, thank you so much. Can we have the next one, please?
Thank you.
Yes, ma'am. Now I would like to invite our next presenter, Bhavna Rana, and she's presenting on optimal route locator mobile app for timber depots using shortest path algorithms. Representative, you may please start your presentation.
Good afternoon, everyone. Coming to our project is mobile application for timber depot management. Coming to the project description, we have developed a mobile application for timber depot management. Um, this actually focuses on government timber depots where the user can easily find out what kind of timber is actually present in timber depots. With compared to the private timber depots, government timber depots will have less price will be very less, and it would also be useful for the user to easily find out what are the various kinds of timbers available. So the user can easily order for the amount of timber he wants. Usually tendering process occurs in timber depots. So the user needs to send an email to the government timber depot. So corresponding to the type of timber he wants. Our problem statement is the customers are suffering with ordering the timber from the timber depots, and they don't know how much of quantity of timber is present in the government timber depots. We want to show the user how much of amount of timber is present in government timber depots so that they can easily order. This is a proposed system where we provide a login for both the user and also for the timber depots management. And we have used the database Firebase for storing the details of the user, where each user can select the district, depots, and select the timbers. As I have said, usually tendering process takes, the user needs to send a request to the government timber depots in order to get the timber, where the depot members will accept the request and confirms the order. We have startingly have created a registration page for the user to log in, and we have used the login page, and the user needs to send our application is connected to the database by using the Firebase. This is how the users where the data is stored in the Firebase. We have 3 types of timber depots in 2 districts, East Godavari and West Godavari. Our project is limited to our AP district. So we have only 2 government timber depots only in 2 districts, West Godavari and East Godavari. Coming to East Godavari, we have only one timber depot, that is Shentur depot. And coming to West Godavari, we have 2 types of timber depots, Rajamandri depot and Jangareddy depot. If the user needs to select the district, if correspondingly if we select the West Godavari, we have shown another drop-down menu of timber depots, Jangareddy. If the user select this, and we have used the A-star algorithm for implementing the shortest distance. This is how our application looks like: login, registration page, and login page, and selecting the district and corresponding depot will be shown. And this is how we have provided a brief description about the type of timber we have chosen. We have 4 types of timbers: bamboo, teak, rosewood, and firewood, and the corresponding will be selected by the user. If he selects bamboo, we have shown some kind of description about that. Here we have shown the depot he have selected, and he need to enter the quantity. The quantity is measured in tons. If he wants 10 tons or 20 tons, he can simply enter the quantity, and if he send here, we send PCF is responsible for maintaining all the type of timbers in AP. PCCF stands for Principal Chief Conservator of Forest, where he will be maintaining all the kinds of timber. And if he entered the quantity, mail will be sent to the corresponding timber depots. And if we select the view route option, the corresponding map from the location to the government timber depot will be shown. And this is the authentication where the user details will be stored. And the objectives is to identify the timber depots, display the routes from the forest to the depots, and finding the optimal route. The optimal route will be given by the Google Maps. We have implemented Google Maps. And coming to our conclusion, nowadays everyone is busy in their own lives and everything is becoming online. So we thought of implementing timber this kind of application where the user can simply order the type of timber and the amount of timber. And these are the references.
Okay, Pavna. So my question to you is, from where do you get the data to work on?
Ma'am, actually, this is developed as per the requirements of APSAC, ma'am. All the details about the timber depots are given by them. APSAC is Andhra Pradesh Space Application Center. So
Yeah.
we have developed the project for them.
Okay. So is it part of your research? Project is a part of your research, or have you proposed a project like after that? You've completed your PhD and then you're applying for a project, or 3-4 of you decided to propose a project? What's the
Actually, we are a group of yes, ma'am. Actually, this is a project, ma'am. In our college, we are undergraduate students, ma'am. So it is a part of our project. We thought of implementing this, ma'am.
Okay, so you haven't. Okay, so have you implemented it?
Yes, ma'am. We have implemented it, ma'am.
And what's the success percentage?
Ma'am, we have developed the project up to what the requirements have given. APSAC has given us, ma'am. All the requirements they have given us, they have implemented them, ma'am. And we have given the project to APSAC, ma'am, so that they can deploy in the place.
Okay, so deployment hasn't been done yet.
Means we have handed it over to them, ma'am. APSAC people.
Haven't they started on a trial basis also?
Ma'am, we have implemented it. Yes, ma'am. They are slowly implementing it, ma'am. As is a new project. What we have implemented up to the mark is perfect, ma'am. We have given to them and they are in testing progress and they will deploy it.
So what's the feedback? Did you face any kind of challenge while making the project?
Yes, ma'am. First, it was a bit difficult for us, ma'am, as we are new and we have going on interacting with them, ma'am. So it has become for us easy to know all the requirements. And then we have started implementing and we have successfully implemented it, ma'am.
How did you think about selecting the algorithm? Why did you think that this algorithm would be the best one, best suited one, I would say, for your work?
Yes. Ma'am, actually we thought of Google Maps, ma'am. So it would be easy and it would be easily accessible for everyone. Even the lay people can also they can easily understand. So that we have chosen Google Maps. They use A-star algorithm, ma'am.
Okay, thank you so much. Good luck to you. So can we have the next presenter, please?
Thank you.
Yes, ma'am. So our next presenter is Sandhya, and she's presenting on performance analysis of ML techniques for spectrum sensing in cognitive radio. Dear presenter, you may please start your presentation.
Yes, sir. I'm going to share my screen now, sir. Just a minute. Okay. Yeah, good afternoon, ma'am. Myself, Sandhya HB, assistant professor, and also I'm a part-time research scholar in the Department of Electronics and Telecommunication Engineering, RV College of Engineering, Bangalore. My topic, my research work, what I have done is performance analysis of ML techniques for spectrum sensing in cognitive radio. My voice is audible, ma'am. Can I continue?
Yes, you can.
Yeah.
I think it's a review paper, right?
No, not review, ma'am.
Uh-huh.
I have done with some ML techniques implementation. I have done, ma'am.
All right. Okay. Please start with it.
Yeah. These are the contents included in my presentation. Introduction. See, cognitive radio is nothing but a radio. Here we can able to program and configure dynamically, and we can use best.
Can you please come to the problem statement because we're already running late with the time?
Yes, ma'am. Come directly
Can
to
we, to the problem statement.
the statement. Okay.
Yeah.
Introduction part I am skipping. Motivation, problem statement. Okay. Objective also shall I skip?
I'm talking about the problem statement. Yeah, you can
Here,
start from.
I simulated different ML-based techniques for spectrum sensing in cognitive radio network and analyzing those techniques to find out the optimal detection mechanism. So here, this is my overall workflow of implementation. First, what I have done is data generation using spectrum analyzer. By using some spectrum analyzer hardware kit, I have collected the real-time data. Then from the real-time data, I did some feature extraction. Then that whatever the data I collected, I put in Excel. Then I've used some ML techniques.
From where you gathered the data?
Spectrum analyzer. I will show you now. This is the spectrum analyzer now. From here, I connected the receiving antenna, and I have set these are the specification parameters I have set. Start frequency and stop frequency, and I have fixed the threshold. And you can see here, I've set.
And how did you decide upon fixing up these parameters? Are they the most, yeah?
I have checked for all the kind of frequency from some 900 megahertz to up to 4 gigahertz. I've observed.
No, I'm just talking about that range.
Minus,
also.
based on the signal value. See, we can decide good signal, bad signal, and very based on that we have decided now.
Okay, and the threshold?
If it is greater than minus 90 dB, like channel is occupied. If it is less than minus 90 dB, channel is unoccupied.
Okay, a generic one, right?
Yeah. Okay, from here I collected the real-time data. Then what I did, so I've extracted in Excel like this. From 10 mega to up to 7 gigahertz. So that I have plotted here also. Okay, then by using PyCaret library from Python, I have run the code and I've used, these are the 4 techniques I have used, KNN, SVM, and decision tree and logistic regression. These are from these 4 techniques, I got some accuracy. Based on the accuracy value, I've decided K nearest neighbor ML technique is selected out of 4 techniques, whatever I have mentioned. This is one part what I have done.
From this current one, we can see almost same results for decision tree and KNN, right?
Which one, ma'am? KNN and? There is a small difference, ma'am.
Yeah. So what made you ended it on
this is
KNN?
one part what I have done, ma'am. From out of these 4 ML techniques, just I concluded.
So majorly you found the best results for
best,
KNN.
which is giving good accuracy.
Okay.
This is one part. Then what I did, I using same thing in MATLAB Simulink. Wherever I found a channel is based on the table, I've decided. See here you can see from 0.01 gigahertz to 1 gigahertz channel is unoccupied. So here I've transmitted some audio using MATLAB Simulink.
So what are your findings from this?
Like I found which band is free. In that band, I've transmitted some audio signal. Just concluding like I've occupied.
Okay, so tell me, what can be the future scope for your work?
Ma'am, in future scope, like still we can see, I have collected data for some band. Still, we can work on for different frequency band, TV band, VHF or UHF band. That is one of the technique. Another frequency band also, we can find out which channel bands are free, so that we can, secondary user can able to use that particular band whenever primary users are not using. That is one thing. And also I can use different ML techniques which will give better result in terms of
So
accuracy.
others must have done something similar to this as well. Don't you think so?
Yeah,
Is there something?
yeah, ma'am. They have done, but I don't think they have done for simulating data, ma'am. Not refer
Or
any paper for real data. Like
okay,
if you
sure.
take for FM band also, they're not
Yeah.
implemented for real time data, ma'am.
Okay, fine.
These are the reference papers, ma'am. Any other questions, ma'am?
All right. No,
Thank
not
you.
as of now. Yeah. All the best to you.
Thank you so much, ma'am.
So thank you for
Next
your great
presenter.
presentation. Yes, ma'am. So now we are moving for our next presenter, Lavanya, and she is presenting on risk prediction near dams of Krishna River using GIS and real-time flooding data. Dear presenter, you may please start your presentation.
So good afternoon, everyone. So our project title is Risk Prediction near Dams of Krishna River using GIS and real-time flooding data. So coming to the abstract of our project. So India had a ranking of 90 out of 181 nations on the index, which is determined by factors such as exposure, vulnerability.
Lavanya, can you come to the motivation of your project? What motivated you to take it up? And is there any other work which correlates with the work that you have done or you've taken up?
Sorry, ma'am, I didn't include the motivation in the slide.
Because that is the most important part of any kind of, I would say, work which we discuss, isn't it? Because we get motivation from some work that has already been done, or maybe there is some gap in the pre-existing scenario.
Yes, ma'am.
So,
there are other ways to implement this project, we can use the sensors to get the readings of the near dam, but which is a cost-effective process, ma'am.
I don't know, I refer to something else. I think you understood it in a different manner. Anyway, so in your work, sensors have not been included, right?
Yes, ma'am.
No physical equipment has been established near dams or nothing of that sort has been done.
Yes, ma'am.
Okay, so
So
what exactly you have done in your work?
So we just collected the readings from our client, ma'am.
So who the client is?
So he's the manager of the Andhra Pradesh State Disaster Management.
Mm-hmm. And what kind of data you collected from them?
Like dam name, total capacity and surface area and total number of gates that dam has.
Okay, so there would be certainly n number of things that you can, the readings that you can take from them, right? But
Yes,
what parameters, I would say, what readings were actually taken for your work, specifically for your work, because you cannot work on all those parameters collectively, right?
So we mainly focused on total capacity of the dam, ma'am, and the current water level of the dam.
Okay, just two of them. That's it.
Yes, ma'am. If and also the number of gates and the height of the gates, ma'am.
Yeah, I'm sure there would be some more, right? There would be certainly, I think, 8 or 10 parameters for your work. How about the GIS
yes, ma'am.
content, like what you took from them?
So we use instead of GIS, we use the Google My Maps to represent the dam parameters.
Okay, can we move to the next slide, please?
Yes, ma'am. So these are the objectives of our project. So first one is the creation of map for dams using Google My Maps, and next one is creating dam database, And next one is dynamic display of data using pop-up of maps. And then we are
So
analyzing how many
didn't you find the pre-existing maps of the dams? Were they not there in the database?
but here we are doing only for the dams which are located in Andhra Pradesh, only for Krishna River, ma'am.
All right, please move to the next slide.
So this was the scope of our
Next
project.
one. I'm so sorry I'm interrupting you in between, but I just want to pick up the most important and relevant part of your papers. Oh, all right. So please make it full view and then you can discuss about the proposed diagram, the system.
Yes, ma'am. So first we will take the current water level of the dam as an input, and then we analyze the input, and if it exceeds the limit, then we will analyze how many number of gates should be opened at what height. And then we will create a map to represent the dam information such as total capacity and the name of the dam and total number of gates it has, and the current water level and the total number of gates which should be opened.
All
And-
right, you can, yeah.
Yes, ma'am.
Methodology.
So the project contains mainly 4 modules. First one is creation of maps for dams using Google My Maps. So
Please move to the next one, Lavanya.
so these are the algorithms.
Yeah, next.
So
Mhm.
these are the data layers we use to create the map, ma'am. So nearby villages, Krishna River, and the dams. So by importing all the previously mentioned layers, we will get a map like this with the pop-up dams. So these are the dams of Krishna River, which are located in Andhra Pradesh, and if this brown area represents the villages nearby Krishna River, and this blue area represents the Krishna River, ma'am. So by selecting a particular dam on the left side of the map, we will get all the information related to that particular dam, like dam name and the latitude, longitude.
Please move to the next slide. Next.
So
Next. Yeah. Okay.
Yeah.
All right.
So
So how many people are there in this project?
3 people, ma'am, total.
And what you all do?
So we just collected the information from the client.
No,
And
Lavanya, I'm asking, do you work in a university or?
Yes, ma'am.
Okay, all
We
right.
are undergraduate students, ma'am. As a part of our
Okay.
academics, we did this project, ma'am.
Okay, all right. So you're on a very right track, I must say, and I must congratulate to you on the kind of work that you've taken up. I think
Thank
it's just in the initial years of its work, right? So it
Yes,
would certainly come and it will certainly be at a better position 1 or 2 years down the line. Good luck to you. Okay, thank you so much.
Thank you, ma'am.
Okay, so moving for our next presentation, I'd like to invite our next presenter, Alagu VRA, and she is presenting on UML modeling for smart light systems, as well as in deserted areas and forests.
So today we'll be seeing a research paper on UML modeling for smart light systems. So we thought of an idea. We've seen several UML modelings for several systems like traffic control systems and reservoirs, and we've seen lots of UML modeling systems. So we thought of modeling for.
Please come to the problem statement slide.
Yes. So our problem statement is that there are a lot of forests in India which contain many highways, and there is not enough electricity or light in those highways during nights for cars and other vehicles to travel, or there is no other facility to check whether anyone's passing the road or any animal is passing through the forest. So we have created a smart light system for the smart light system for rural areas. So now the flow of the smart light system. So our smart light system consists of 2 sensors, and one sensor is used for detecting the the motion of any object that is placed 10 meters away from each light. Another sensor is for collecting light energy and converting it into electrical energy. So once at day, the sensors collect the solar energy and converts the collected energy into electrical energy. And at night, when an object passes, that is 10 meter before each light, we have planned for placing or embedding a sensor. So when the car or the object passes through the sensor, the light gets alerted and it illuminates for 10 seconds. So we have done UML modeling to actually propose this concept so that it can be used in the future. And for more understanding, we've also proposed UML 7 different UML models for our smart light system. So one is like use case diagram. This mostly used through use case diagram. You can see the external view or the structure of the system. So it is a conceptual representation of the system. So once a human or vehicle, an actor passes through the sensor, the solar light is alerted and it illuminates for 10 seconds. And if there is anything to be maintenance issues or any cost to be reported, it will be reported to the admin. And at the time at which each vehicle or animal or human crosses the sensor will be recorded and saved in the database so that that data can be used for further research purposes. We have the design path diagram where all the objects of our list are represented as classes which contain attributes and their and the work done. So, for example, let's take the road, which has the name and ID, and insert sensor. That is the insert sensor in the road. And similarly, we have all the other 4 components of the SPS. Next is object diagram. So the object diagram is for representing instances in the system. So the instances of the system includes the moving objects, the roads, the vehicle, whatever moving object is, vehicle, animal, or human. This object diagram is completely done only to show what are the objects involved in the system. Next is the sequence diagram. A sequence diagram is a timely ordered diagram which shows what is happening in the system from the beginning to end in a sequential manner. So the first thing which happens in the system is that light is absorbed and it's stored in the sensors. Then once then only the system activates when an object passes through the sensor which is embedded in the road. And when it passes, the system is alerted and it illuminates light. If there is any problem in illumination, a maintenance check will be run and issues will be reported to the admin. As we can see in the steps 8, 9, 10, and 11. Next is activity diagram. The activity diagram is more or less like a flowchart of how the system works. So once from the top, when the system starts, when a car or an object passes, motion is detected, the power is checked. If there is enough solar power, solar energy is converted to electrical energy, it is used. If there is not, in case if there is no solar power which is being converted into electrical power is not available, we have also planned of installing electric batteries, so it can illuminate light for that certain hours. And then the database will be updated that there is a problem with the system, and it will be sent to the admin, and the data and the entire system will be checked for maintenance. So component diagram. The component diagram is normally used to show the components of the system and the functionalities of a system. Our smart light system consists of 4 main components. A smart light system itself is a component of backup and recovery, the sensor data, and the database. So the major components are these. The backup and recovery contains the data. Backup and recovery contains the actions taken by the smart light system when there is a problem or a maintenance issue. The database consists of the time that when object passes, the time that is recorded, all the time.
Can we move to the next slide, please?
Next is the deployment diagram. This is the final diagram, and through the deployment diagram, we have shown the nodes of the system. That is the topology of the system's physical components. It contains two nodes, the sensor and the smart light system. So the sensor has two sensors and the data stored in it, and the smart light system has the components, the system itself, the backup and recovery component, and the database component. So the conclusion is that we have proposed this concept in order so that in future when this can be implemented throughout India, people will get a more people who want to implement it will get a more or a better idea on how to implement the system. And this is a system; it's a very efficient system. It lessens the cost and it also reduces the use of electricity. So we hope that this will be very helpful in the future when there is a sense of implementing this in all forests. So these are references. Uh,
Okay, Alugu. So is it a part of some kind of project or your research work?
this is our research work, ma'am. It was done by myself and
You
my
are a
colleagues.
research scholar, right?
No, ma'am, we are currently pursuing my PhD. We are undergraduates, and we were our professor supervised us for this paper.
I didn't get you. Like, it's a part of, is it a part of your curriculum?
We had a subject called software engineering. Since we had interest in it, we just wrote a paper on the concepts that we learned.
Okay, so whatever you have presented here, it's just on a conceptual level, right?
Yes,
Yeah.
it's on a concept.
Okay. Okay. So tell me, you've selected forest areas specifically, and we're talking about sunlight as well, right? Solar energy. So the
Yes, ma'am.
biggest challenge which is going to be for your work would be the solar energy or the sunlight reaching to the sensors which you're planning to install, or I would say use in forest areas.
Yes, ma'am.
Isn't it? So how do you plan to cope up with that?
As for the sensors, we first thought about increasing the height of so that it's taller than the trees. Once it's taller than the trees, like a place where there's no street, we get direct sunlight. We only thought about that actually.
So mitigating it through the height, balancing through the height, right? Uh, what would do you really think it's going to be, cost effective, and can we use some wireless sensors instead of the such kind of I would say stationary sensors which you're talking about installing above the height of the trees, right? Don't you think it would be more sensible to have wireless sensors?
Yes, ma'am. It would be really better if we have wireless sensors. But as for the cost, like using solar energy sensors is like one-time investment. Like we can, though it costs.
No, so wireless sensors based on solar energy. Don't you think it can be a good combination for your work?
Yes, ma'am. I
Yeah,
believe it
and
would
then
be.
we'll have to take the cost plus the battery life also into consideration.
Uh, yes, ma'am.
Yeah.
That could
So
take the cost.
yeah, so the concept is, I would say, on a very, very superficial level. You'll have to look into the challenges, the costing part, thoroughly before thinking about, proposing something related with it. Yeah, isn't it? Yes, Alubi, can you hear me?
Am I not audible? Hello.
Okay, that's okay. So I was just suggesting you to take the costing part and the costing and the other factors which I mentioned for your work. Yeah.
Okay, ma'am. Am I audible now?
Yes, yes, you are audible. I'm just telling you to keep a few things in mind before even thinking about conceptualizing or proposing such work. Uh, the topic that the idea that you've taken up requires a lot of study related with the challenges of the concept. All right. All the best to you. Thank you. Can you wrap up the session?
Yes, ma'am. Thank you for your great presentation, Olago. Okay. Now, after completing all the presentations, I sincerely thank our authors for their excellent presentation and great contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. And we, on behalf of whole team, thank you for your support during this version and the previous 6 version of this conference. And we will be happy to have you all in the 8th version of this conference in 2023. Moreover, all the participants will be getting their digital certificates within 2 working days, and the publication will be live within 5 to 6 months. Further, all the papers have been forwarded to the printer. So kindly cooperate with the team ICTCS 2022 and the Global Knowledge Research Foundation. Just before we end the session, I also thank our session chair for chairing the session. And ma'am, there is a token of appreciation on behalf of to chairing the session on behalf of Global Knowledge Research Foundation and ICTCS 2022.
Thank you so much, Harsh, for the kind words, and everyone for having me here. It was indeed a very wonderful knowledge sharing session. My heartiest congratulations to one and all who are there in this session, and good luck ahead. Hope to have you all somewhere in some other session with enriched values. Thank you so much.
Thank you, ma'am, for your presence over here.
Pleasure. Thank you so much.
Now, in the end, I would like to request you all to turn on your camera to collect some good memories of this virtual conference.
I'm so sorry, Harsh. I won't be able to turn the camera on because I'm connected with the institute PC. So
No worries.
it won't be possible. Yeah.
No worries. No worries. Okay. Thank you so much for your great presentation, and thank you, ma'am, for presence. Thank you for your presence over here, ma'am.
Thank you. Thanks, everyone. Yeah.
Please stay safe and take care, everyone.